Hello and welcome to today's Tech Nugget, where we will be discussing double block and bleed on the coke drum structure. I'm Evan Hyde, your host today from coking.com, and we're going to be talking about something that is literally the bread and butter of every delayed coker in the world. But this is why all the valve manufacturers love us so much, because we end up having to buy all of our valves basically in duplicate. And that's because the delayed coker is one of the few refinery units that is opened to the atmosphere every single day. As such, we rely on the positive isolation of two valves in almost all cases. I'll talk about that in a little bit, but two valves where we are giving positive isolation to atmosphere. So this is something that is sort of foundational to the way a delayed coker works. So let's go into some of the more specific details that I know you're all here to learn about. So we're going to talk about two different types of double block and bleed arrangements. We're going to talk about the closed spool arrangement versus the flowing spool arrangement. Now, the closed spool is in fact the most often used situation in my experience, which is basically where you have block valve A, block valve B, and a pipe spool between the two, and this provides the double block and bleed potentially. So we'll talk about the bleed in a minute, but that's where the positive isolation is occurring, because you want to have a higher pressure in this spool zone than whatever is going on outside. And the higher pressure, along with the positive integrity of the valves themselves, is what gives you the reliance and the confidence that you can safely do whatever you need to do at atmosphere without any risk to any of the personnel in the unit or the environment in general. So the closed spool is, we call it closed because you typically blocking steam in to that pipe spool. So both valves are in the closed position. You bring the blocking steam in, and you typically have a drain off of that spool. Now, when the valves are in their open position, you want to have the steam coming in shut, and you want to have that drain shut as well, because you don't want things going places where they're not supposed to be. But when the valves are in their closed position, you're going to bring that steam into the spool, pressurize that spool, potentially keeping any of the nasty stuff back in the process, not getting out in an atmosphere. That pressurized spool can build up with condensate over time, and this can be managed, and we'll talk about how to manage that in a second. But what you need to do is just pressurize that system, hold everything in there, make sure it's good and tight, and life is good. Bob's your uncle, right? Now, you will want to drain that condensate out before you move to the next step in the sequence, because a leg of condensate can cause all kinds of trouble. Most importantly, on the drum vapor lines is where we always see the biggest issues with this. So the vapor lines in some larger units can be 24, 30 inches or larger, with a pipe spool that can be 1 meter in length, and this turns out to be an exceptional amount of condensate that if it were to flash into steam, we know that's water to steam transition, that volume expands something like 1,600 times, Gary used to love to say, and this flash of water into steam can cause all types of damage, especially in the fractionator or the blowdown. So we generally don't want that to happen. So we want to get that condensate out in a more controlled way, so we open that drain valve. Now, this is a coker, right? So turns out drain valves are also low points in the line where coke likes to accumulate. So hopefully that drain valve is reliable for you. The layout of your piping is good. We've tried a number of things where people have added steam purges continuously going through a restriction orifice to try to keep that nozzle free. Sometimes that helps a little bit, but realistically the best way is to just kind of have a very reliable process to make sure you're opening and flushing that steam out with a good purge before you move the big valves, and make sure you get anything that's kind of accumulated in that little stump of pipe out to the place where it's going to go. So now I'm going to talk to you designers for a minute. When we say minimum distance on the P&ID, we mean minimum distance, because anything longer than what is absolutely necessary can become a spot for coke to accumulate, rendering this whole drain concept basically useless. So minimum distance is important. However, there's a flip side. These are often big lines close to the deck, and we need to have accessibility to those valves. So me personally, and we at coking.com always recommend that those valves be quarter turn valves, or even better, solenoid valves, but that's exceptionally rare. But quarter turn valves are a lot easier to operate on a daily basis because you just have to turn the valve quarter turn, it's open, life's good, versus a gate valve. You got to get in there and use a pipe wrench and turn it. And quite often the valve placements here are sort of up and under the lines, really kind of difficult ergonomic places for the operators to do their job. So really spend some time when you're laying out this pipe and think about A, minimum distance, but B, ergonomics and operability over these drain lines. Because I've seen some ones that are laid out amazingly and the operators are very fortunate there. And I've seen some ones that are laid out very poorly, and I feel bad for those operators on a daily basis. You know who you are. So let's talk about the second thing now, the flowing spool. So the flowing spool is used less often, but it is a trick that can be used to typically buy yourself some time, especially when you have some valves that you know are maybe not quite as reliable as you'd like, maybe a little suspect, and you have a maintenance window coming in days, weeks, or potentially months that you want to just get yourself that little bit of extra time. So when we talk about flowing spool, it's, as the name implies, you bring the steam in just like before, but we crack that drain valve open a little bit, and that allows the system to blow continuously to wherever the downstream destination is. And now that sounds well and good. You say, well, why wouldn't somebody just do that all the time? Well, two reasons. One, because it uses a lot of steam, and two, it can actually sort of cause upset conditions to whatever, again, that downstream vessel is, because it's generally not designed to take steam like that on a continuous basis. So it is something that we do. So basically when you're going to set this up, you're going to crack that drain line open, but you want to make sure, again, you maintain that positive spool pressure. So you want material to flow through the system, and you can usually hear it pretty clearly. But you want material to flow through that system and if anything on the upstream valve, if it's kind of leaking just a little bit, it's going to go out the drain preferentially than going to atmosphere. So again, this is all about safety, all about the fact that the delay coker is open to atmosphere more often than any other unit in the entire refinery. So that's the flowing spool. One last point about the flowing spool. Generally, the flowing spool works a little bit easier in my experience around the drum inlet side. I know that's where you kind of think about coke because it's at the highest temperature, which is true. However, we have to remind ourselves that the material that's flowing through the pipes at those temperatures hasn't been at that temperature that long, so it probably hasn't produced coke yet. And it also flows like water at these temperatures. So it's moving around very quickly, and if you get it through the system very quickly, you knock it down temperature with the temperature with the steam, then you're probably not going to form that much coke. But on the opposite side, the drum vapor side, you have a stickier substance coming out of there. It's had more time to react. It's carried some solid coke over with it, a little bit crunchier. The flowing spool is a little bit more problematic on the drum vapor side, but again, this is a trick that sometimes we do to buy ourselves some time. So let's talk about, lastly, where this system has failed us. Now, there have been a number of incidents in our world where double block and bleed hasn't prevented us from a loss of containment. Some of those are more publicized than others. During our training sessions, we go through a big, long discussion about all the different instances, at least that we're aware of, where this has happened, led to a major release, major incident, fire, injuries, or deaths, unfortunately on a number of cases. But this is something that we rely on the interlocks for. The interlock system is absolutely mission critical to make sure that you're making the right moves on the right valves at the right time. And especially with multiple module cokers, it can get very confusing. Even on a 2-drum coker, people make mistakes. So it's important that you have an interlock system, but not every site does. They often rely on lottos or cables or some sort of other mechanical system to prevent people from making the wrong moves at the wrong time. So we always advocate for interlocks. It is by far the best practice. However, if you don't happen to have those, which I know there are a number of older sites out there in the world that are still sort of on the path to getting interlocks, and it takes a lot of money and a lot of time, but make sure that you have a robust system to make sure that you are maintaining this double block and bleed at all times. And that brings me to my 2 final points for today. So we talk about double block and bleed all the time for hydrocarbon to atmosphere, and this is very important. Now, there are a number of units out there, new and unfortunately old, where there are scenarios in the drum cycle where you can be relying on a single point isolation of hydrocarbon to atmosphere. And this is here, this year, in the 21st century, that is completely unacceptable. There are ways to design around this, and there are ways to retrofit situations to rectify this problem. So double block and bleed is absolutely the industry best practice, and we've participated in HAZOPs, equipment site audits around the world, where we've sort of stumbled on these situations and they go, oh yeah, I never really thought about that with my antifoam. Or that's usually a conversation I might have with an engineer, but more often than not, when I mention it to the operators, they're like, oh yeah, we've known that's been a problem for a long time, but we just deal with it. So this is something that can be risk assessed. Project justification can be made to make sure that these things are eliminated because they are serious safety concerns. So 2 valves preventing hydrocarbon from going to atmosphere all the time are the industry best practice, but I will mention that recently there are a number of vendors who have been qualified by certain refinery operators or by certain licensors to use a single block isolation in lieu of the double block, and these valves are very specially designed for this specific purpose. So the one that comes to my mind first is the delta valve isolation valve, and it basically functions similarly to the bud or tud that we're all familiar with on the coke drum itself, which is a slab valve with a body that is maintained with a positive pressure onto itself that can be independently instrumented and maintained at a process pressure above, the process, to make sure that you're getting, again, that double block and bleed and that positive verification that you're not going to get anything leaking to atmosphere. And they do that through a combination of elaborate internal gate and seat assemblies, again with maintaining active seats on both sides, and those live loaded active seats with a positive barrier pressure is what allows them to qualify as a double block and bleed in a single valve. I know there are a few other vendors that are doing it as well. Like I'm thinking about Valve Technologies, thinking about MoGas. So there are a number of vendors who do it. However, the pantheon of ball valves, wedge valves, and normal knife gate valves do not meet this very, very strict criteria for 2 for 1. But it is something that does exist, and a number of sites have used it because they are potentially space constrained with adapting an older unit that had a single block into a double block, which takes a lot of extra space. So something to consider. Now, we've spent a lot of time today talking about something which seems fairly mundane, but it is absolutely life and safety and environmentally critical to the operation of a delayed coker. Hopefully you learned something about the double block and bleed system. Maybe you have some questions. Feel free to reach out to us at coking.com. I'm Evan Hyde. This has been your Tech Nugget.